How you guys doing? Hope everybody's doing well today. Thank you for joining us. I figured I would put this together and hope you guys enjoy it. There's a lot of people that don't know how to read plans, and I figured, hey, why not do a live chat where we can, I can show you guys what I know about reading engineer plans. So let's wait for a few more people to kind of join in. We have so far we have 30 people watching. So if you're here, say hi. So let me know if you're building a Barndominium or what your deal is, so that I know there's a lot of people that I invited that are in the concrete construction business, maybe some new guys, and I'm hoping this will help everybody. This is engineer plans is one of those things that when I look at it, it seems pretty basic to me now, but I remember there was times where it was I didn't know anything. So I'm gonna go ahead and share this with you guys. Let me see what's going on here. All right, so let me see what's going on here. I'm trying a different screen here, and to be honest, I don't see anybody. I mean, I see you guys are here, but I don't see anybody typing anything, and I'm assuming you guys are typing, but I don't see it. So let's see what's going on. Yeah, you guys are typing. I can see it on my phone, but for some reason I cannot see it on my screen. Anyway, so we're gonna have to play by ear, I guess. Like I said, I can see it here on my phone. Yeah. Anyway, let me give me a few more minutes, see if I can figure this thing out. Okay. Everything looks good. Anyway, give it a few more minutes for people to show up. In the meantime, I'm going to try to figure this thing out. Let me move it over here where I can see it a little better. I'm going to try to type something here. Hopefully you guys can see me. Okay. Yep. Mine showed up, but for some reason I cannot see yours. That's strange. Anyway, I'll just have to try to see it on my phone. Tony, happy birthday, Tony. Steve C. He's been in business for 40 years, experienced reading plans. Just want to say hi from Del Valle, Texas. How you doing, man? Welcome. WR Farms is here. All right, so I don't know what's going on with this thing. I cannot see the chat on my screen, but I can see it on my phone. So we're just gonna have to run with that. Okay, how about that? All right, let's get going. All right, so these are, all right, let me read a few comments. Make sure that I can see you guys. I am here from South Carolina. Hector Aguilera, just want to say hi from Polk County, Florida, and concrete contractor. Weird to be following you for a minute. Well, welcome, man. How's your day? Everything's good here. Try and refresh the website you are on. Man, I'd hate to do that because I'm afraid I'm going to lose it. But you know what? I'm going to refresh it. Cross your fingers, cross your fingers, cross your fingers. Oh, my goodness, that worked. Thank you. Thank you so much, Tyler Hossman. All right, now I can see everybody. Awesome. All right, so let's get rolling. And let's get going. All right, so engineered plans is something that everybody needs to learn how to read, or at least needs to understand them, right? Especially if you're a contractor. If you're a builder, you need to make sure that you understand them, because you want to make sure that when they do the concrete, that they do it properly. Tom Rowe, how you doing, Tom? So Rob Donaldson is asking if I like 1/4 inch or 3/8 scale. I actually like 1/4 inch. It just seems to be the standard. And believe it or not, that's something that we're going to discuss today. Is a lot of people do not verify scale. They just go right in and start scaling plans. You need to verify scale first. So, all right, let's go over to the plans. So this is the plans that we're going to be looking at today. These are fairly simple plans, and they are this is for a Barndominium that we're doing right now. This is a so you can see across the top, it's 56 feet 5.5 inches, and that includes. So you have to make sure that you see everything. So let's look at that first dimension at the very top. This one up here. Okay. It's 56 5.5 inches. Okay, let me see if I can highlight it for you guys right there. 56 5.5 inches, and the other dimension is 46 foot 8 inches. Okay, so you want to make sure that that's really kind of where you get going. Okay, that's the extreme dimensions. But you have to see where it goes. It goes from this edge right here all the way to here. So those are not your slab, your building dimensions. That includes everything. And this right here is just a small porch off the side. This one right here. This is a small porch. So, don't get confused and think this 56 5.5 is just your main slab. It's not, okay? So that's your most extreme dimension. Then you come in one more dimension, or one more in right here, and then you have 50 feet 3 inches. That is your from here to here. Okay, that's going to be, in this case, this is the size of our slab for our building. Okay, so. And then you see that past here you have another dimension, which is 6 feet 2.5. That's the dimension of our porch. That's a small porch. This porch is 6.5 or 6 feet 2.5 inches by 8 feet 8 inches. Now, here's something extremely important that you need to know. These are engineer plans. Okay, look down here. Look what it says down here in the corner, right here. Okay. This is a disclaimer. Very important. Okay. It says builder or contractor to verify all dimensions, floor penetrations, drop areas, block out locations on site. What does that mean? That means don't trust these plans. That's pretty much what it means. Okay. So what do you trust? Well, you have a set of plans from the architect. Those are the plans. See, everything starts with the architect plans, okay? And I should probably have started with those, but okay, we'll do an episode on those, on how to read those plans next. I just want to do these because these are a little simpler, but everything starts with the architect plans, okay? That's where your building starts, okay? So, you submit those architect plans to the engineer, and they designed these plans right here, okay? So pretty much that's what they're telling you down here in the corner. They're saying, you know, right here, they are saying, do not trust these plans. These dimensions are not accurate, or they may not be accurate. So, you know, make sure you know what you're looking at, and if something's wrong, you need to figure it out. Okay, that's pretty much what they're saying. Okay, having said that, let's go back to the plans. And so you have your dimensions there. Okay, you have your, you know, like I said, you have these dimensions here. And so all it's saying is you have a 50-foot 3-inch slab, and then you have 6 feet 2.5 porch. Okay, the other dimension for the porch is right here. It's 8 feet 8 inches. And on this side over here, you have 46 feet 8 inches, and it goes from this line to this line. Okay, that includes your back porch, your slab for your living quarters, and your front porch. Okay, so then you move in one line, and that tells you how wide your living quarters are. Right here, this dimension right here, that's 30 feet exactly. That's your living quarters. Then you have a front porch, which is 6 feet 4 inches right here. And then down here, you have the back porch, which is 10 feet 4 inches. Okay, so it's, as you guys can see, you kind of start on the outside and move in. Then this dimension right here, 15 feet, then you have it again. That just tells you the dimension to the center of this beam. Okay, that beam, that's where your beams are. Okay, so as you guys see, it's fairly simple. Okay, but you know, you need to make sure that you pay attention, and of course, you know, you need to cross-reference all these dimensions with the architect plans. Okay, so again, they have a disclaimer, so you know, read that disclaimer and make sure that you verify everything. Okay, all right, going back to the plans. Down here, this square right here, it's showing you where the shower is. Okay, there's the square right here, and then it's showing you right here, it says 3.5 inch drop. Okay, we drop all of our showers 3.5 inches. That's all that's telling you. However, you need to verify that it is in the correct place, because like I said, they're likely made a mistake and you need to catch it. So somebody's asking me if beams you refer to footers. Yeah, so these beams, I call these beams right here. These are the beams, okay? And then these are the footers. We actually have footers on all over Barndominiums, right here. These are footers, okay? So these footers right here is what I call footer. So, all right, so now we have all the dimensions, right? So this dimension right here on the top, across the top, the first one's 17 2.5, the next one's 17 6.5, the next one's 15 foot 6. Okay, that tells you the spacing on your beams. Okay, that's how far apart your beams need to be. Same thing on the side. Over here, they tell you they're 15 feet. You know, so that's what that is, right? So in our case, we have these footers right here. Everywhere that we're going to have a pipe, we have these footers. Okay, it's a diamond shape, and we have that everywhere. Okay, so that's what that is. Okay, so far so good. You know, right here, let me see if I can erase all these real quick. Okay, right here, do you see these diagonal lines right here? It has a note right here. It says 3 number 4 additional slab reinforcement bars, 6 feet 8 inches long at 45 degrees, 6 inches from corner at 6 inches on center, typical. Every time, this is pretty standard. Even if the engineer forgets it, you need to put it in. Every time, this is what I call an inside corner, and this is called an outside corner. See how it's a backwards corner? as opposed to this one right here. Every time you have a corner like this, you need to put your diagonal right there, okay? Because if you don't put this diagonal here, you're gonna end up with cracks right here. This is a stress point for your slab. So you're going to get cracks from this corner going in like this. And that's why you need to put those diagonal bars right there, okay? Now, we have more notes in here. This note right here says 6x6 welded wire, fabric recommended. See, it says recommended. Tied to the top of a pad steel in garage, tiled, and stained concrete areas to mitigate surface cracking. This is in addition to require slab beam reinforcement. So this is a recommendation, okay? So you can do it, but it is not required, okay? So, you know, they will put notes on here to kind of see what you want to do. You know, it's obviously it's not required, but it's a good option. Having said that, we do not do the welded wire. We've tried it and we still get cracks, okay? And we're gonna get to the cracks here shortly. All right, down here, here's another note. This is interesting. For foundation site fill depth greater than 48 inches, construction of interior concrete piers are required to mitigate potential slab differential settlement due to post-pour consolidation of the fill material. Refer to Standard Detail 13 and General Notes 6B. So this, you know, this is all stuff that you need to read, okay? So if you have, for example, if your slab looks like this, let me try to draw it for you. If your pad, you know, if your ground looks like this, and then you come in and you build your slab, you fill it in like this, and then you put your slab on top. If this is from here to here, if you have more than 48 inches of fill, you need to put piers in there. So, you know, got to read these plans. What happens is, if you don't follow these plans to the T, when the, see, you have to do a pre-pour inspection. You cannot pour until you pass by the engineer. Otherwise, it is not an engineer foundation, okay? This is what the engineer tells you to do. And without a pre-pour foundation, without a pre-pour inspection that you passed, technically you don't have an engineer foundation, okay? So you need to be able to pass, or your builder or your concrete guy, they need to have proof that they passed this inspection, because until then you have nothing, okay? And obviously the only way to pass it is if they do it exactly like the engineer recommended. So all these notes are very important, okay? Now let's go. Oh, by the way, down here it tells you right here, it tells you the scale, okay? So we kind of touched on that real quick, but the first thing you need to do, for example, you need to find a dimension that is fairly easy to read. For example, this one, 15 feet, okay? You need to scale with your tape measure, and you need to make, you need to scale from here to here and make sure that you get exactly 15 feet. Because if you don't, then your plans are not to scale. Now, if you don't need to scale anything, it doesn't matter. But because you can simply follow these dimensions. But if you have to scale anything, you're going to be off. Okay. So anyway, that's where we're at so far. Let me read some comments right quick. Could you discuss the reason for not using post-tension style? I don't have a reason. I'm going to do a video soon about it because we quit using it, but it's mainly because of, it's not because of low performance. It's mainly because it's a nightmare to get it done around here. You have to send subs back and forth. It's a nightmare. But anyway, do you guys have any questions so far before we go on? Is this pretty clear so far? All right, moving on. All right, so that's the first page, okay? This plan happens to have 2 pages. So you see these numbers right here? Excuse me. This number's right here. See how it has a 2? This one has a 1 right here. See that? This one has a 3. So we're going to go over what all that means. And all these footers right here, they have F3, F2, F4, F4, F2. So F2, 4, 4, and 3. So what does all that mean? Okay, so let's look at 2 first. Okay. So the 2 right here, let's look at this one. So you have to, what that means is notes on page 2, okay? So you're gonna go to second page, okay? And you have to find number 2 right here. This is number 2 right here, okay? This is number 2, okay? It's right here. It says exterior beam, no brick lug. It tells you right here exactly how to build this beam, okay? You have to have, see, a lot of people ask us how come we don't do the vapor barrier all the way to here. Right here, this is why. This is where they're asking us to end the vapor barrier. It says right here, end vapor barrier 6 inches from bottom of beam. So that's how we do it. Again, you have to be very careful to read everything because that's how you have to follow their plans. I mean, different people do it different ways, but this engineer is asking you to do it this way, so you have to do it that way, okay? Or you may not pass inspection, okay? Here's your stirrups, okay? And it tells you right here, see the ground outside the foundation? This is the outside. It tells you that you need to have your ground sloping this way, and it says see chart. See this right here? Right here, see chart. Okay, and we're gonna go look at that chart here shortly, but let's look at the rest of the notes. It says where height exceeds 3 feet, refer to note 4-8 for intermediate bars. So see these bars right here, these mid bars or intermediate bars, they are not needed unless that beam is deeper than 3 feet. So you need to have 6 inches minimum of the select fill, and then it says typical beam reinforcement. Here's a note: if beam height is to exceed 8 feet, refer to detail 15. Okay, so I'm telling you, when I say you need to read plans, you literally need to read the plans because it's all here. Okay. So let's look at, it says here, see chart, okay? So let's look at the chart. This is the chart that they are talking about. Down here, okay? So, this is a chart, okay? Let me try to highlight it a little better. So this is the chart. Okay, D height is asking, what does no brick lug mean? Okay, so imagine a foundation that looks, here, I'll show you right here. This one right here. See how the foundation goes this way? Right here, and then it drops down and it goes out. This right here. Right here. Let me show you a little better. This right here is your brick lug. It's just a lug that drops down. You know, your foundation's like this, drops down 1.5 inches, and then goes out 5.5 inches, and then goes down. And right here is where you're gonna put your brick. The reason for this 1.5" drop is so that water doesn't go inside your house. Okay, so that's what it means by no brick lug. Okay. Whoop. All right, let's go back to the chart. All right, so this chart right here tells you what you need to do, what you need to know. Okay, it talks about the soil information. So we submitted soils. We submitted a soil information. So this is what they used. So design level B, the soil type: brown to light brown, stony, cobbly, silty clay, moist, moderately dense to very dense. Okay, PI is 23. PI stands for plasticity index. The lower the better. Okay, within reason obviously, but 23 is very good. If you get above 30, you're starting to get into very expensive soils. So that's how that works. You know, who it was done by and when they did the soil report. Okay. Here is the chart that you need to really pay attention to. Okay, this is your beam and slab information right here. Okay, so your beam width, how wide those beams need to be. They need to be 10 inches. Okay, 10 inches wide or wider. They can be wider. So exterior beam depth, that means how deep your perimeter beams are. 27 inches minimum. You see that it says minimum there. Okay, they can be taller. Obviously, if you have a sloping ground, you can have, you know, whatever, you know, as you saw up there, this, you know, they have a different detail if you go above 8 feet, but minimum is 27 inches. This one is super important right here. It says exterior beam depth in grade. What that means is you have your perimeter beam here. I'm going to try to draw it over here for you guys. So you have your perimeter beam. So let's just say you have, back to your fill dirt. Okay, this is what your pad looks like, and then you have this much fill right here. Okay, and then you come and you put your slab up here. You know, your forms. Okay, and then you come in here and you dig your beam right here. Okay, and you know, you come in here and then you go, you know, 27 inches from here to here. Okay, and let's just say you have you know, your fill dirt is, you know, let's just say 24 inches from here to here. Okay, you need to be 27 inches minimum, but also you need to make sure that you are, like it says here, 12 inches into grade. Grade means undisturbed ground. See, this right here is all fill dirt. That does not count as grade. Okay, so you first have to get through all this fill dirt. Okay, first you need to get through that fill dirt, and then you need to go 12 inches into grade. This is your grade. Okay, so if you only go 27 inches, you are not going to pass your inspection, because you have to take those two into account. You know, the exterior beam depth of 27 inches minimum plus your exterior beam depth in grade. Okay, so that's very, very important. Okay, and I've seen people fail foundations because they did not pay attention to that second, you know, exterior beam depth into grade, because again, you have to, they go together. Okay, so Enrique, he said, I think Manny made a video about that. Yeah, I went and checked, and he did not take this one into account, the into grade, so we had to dig it up after the rebar. After the rebar had been put in. So Manny learned his lesson, and you know, he did not look at the second one. So yeah, Manny made that mistake. So anyway, moving on. The next item says interior beam depth. That's pretty simple. That just means your interior beams, how deep they are. See, you have perimeter beams, and then you have your interior beams. The interior beams need to be 24 inches minimum, okay? Now you have, right here, you have beam bars. You have 2 number 6 on top and 2 number 6 on the bottom. That just means your rebar. You're gonna have 2 number 6. Number 6, the numbers on rebars talks about what that number means is how many eighths are in that piece of rebar. So a number 6 is 6/8, okay, which means it's a 3/4 inch rebar. That's what that means. And you know, typically we use a number 3, number 4 on the mat, on the surface. That is your rebar. You know, number 3 is 3/8, number 4 is 1/2 inch. So on and so forth. Speaking of that, here is your stirrup for the exterior beams, right here. And the stirrups are number 3s, which are 3/8, 21 inches on center. That's what that means. So your stirrups need to be every 21 inches. For your interior beams, also number 3s, 21 inches on center. So same thing. Pad bars. These pad bars right here are your rebars on the surface, okay? And those are number 3s at 14 inches on center, okay? So this slab is gonna take rebar and they're gonna be spaced out on a grid 14 inches on center. Slab thickness is your last one right here, and it's 4 inches for this particular slab. The square footage is 2,398.81 square feet. However, you must remember that the disclaimer that tells you that, hey, we're not so sure that that's what it is. So you need to verify all that. Okay. Any questions so far? Let me read some comments from you guys. I think you made a video, but yeah, Manny. Let me see. Any questions? Can you make, Ramon Garcia, can you make a video on how to square a building on the future? I have that video, Ramon. Go to my early videos, and I did one on how to square up a foundation. It's one of the very early ones. So, you know, go to our channel, go to the very beginning, and I have one on there. It goes into very deep detail on how to do that. What's the diagonals on the footers? Oh yeah, we still got to talk about that. We'll get there. We'll get there. Who does our slab engineering? We use GE Reeves Engineering. That's who we typically get the plans from. Are the bottom bars tied to the other metal to keep? Are the bottom bars tied to the other metal to keep them off the bottom of the trench? Yes, they are tied with the stirrups, and of course then we put bricks under there to, you know, you do not want your rebar touching dirt anywhere or touching your forms. Your rebar, if you look at these drawings right here, it is very clear that they don't want right here, you know, it shows right here. Every drawing that they have shows, you know, rebar. Of course, here's how you're supposed to tie your corner bars. Right here, okay? So, I mean, they give you very detailed drawings, okay? Of how to, this is your corner bars right here, how you're supposed to tie them. And tells you right here, these are your stirrups. And remember, these are 21 inches spacing. You need to have stirrups at the very end. This is one right here where people a lot of times will fail inspection. A lot of the rod busters, you know, the guys that do the rebar, they start with this stirrup right here, and they start with this one here, and then they tie these bars here, 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 and here. And same on the bottom, and then they come in and they do the quarter bars, and they're done. And then the engineer will come or the inspector, and the first thing he's going to notice is that these stirrups right here are missing. And guess what? You need to put them in while he's there, or you're going to fail your inspection. What does that mean? That means you're gonna have to, one, delay your pour. Number two, you have to pay for your inspection again. Okay, so you do not want to fail your inspection. Of course, you have more notes right here. It says corner bars are the same size as top and bottom bars and exterior beams. Number two, right here, this one's important. Bar laps should be a length of equal to 40 diameters. What does that mean? Well, you multiply, we're doing number 6 right here. So you multiply 3/4 times 40. That's 30 inches. Okay, so your beam laps need to be at least 30 inches long. Your laps, they can be longer than that, but minimum 30 inches, and they will check that. So be very careful. Okay. Let me see. Got it. Didn't see that drawing earlier. Okay. Hey, Eric, have you worked with Helix micro rebar? I have seen only good things. I have not. I have not worked with that. Not yet. I like experimenting with stuff, and hopefully one day soon we will try that. So, okay, let's go back to more notes on these plans. Okay, somebody's asking about the footers. See these footers right here? Not there, but here, like this F4, F2, all that is on page 2. Okay, here's the footers right here. This is how they need to be done. Okay, and it tells you, your A dimension. You have your A here and here, and then of course you have this one here and here. Okay, so this is half diamond and this is the full square. Okay, so those are the two types that you have here, and right here, this is the half one and this is the full one. Okay. Oh, I'm sorry guys, god dang it. All right, let me start over. So sorry about that. So the diamonds that we're talking about, the pads, you have two types. You have this one, which is half, and then this one, which is full. Okay, and then you go to page 2. Here we go. Come on. All right, here we are, and here they are. Okay, here's the half, and here's the full one. Okay. All right, and then you have your A dimension. Okay, and it tells you how to tie the rebar. Okay, it tells you bent bars, C footing chart. So that means we have a chart that we need to look at. Here it says number 5 bars, 12 inches on center each way, 3 inches from bottom of footing. So you need to do 3-inch bars, and then right here you have number 4 vertical tie bars, 12 inches on center, typical. And those are these dots right here that you see right here. See these dots right here, and these bent bars. This is the ones that they're talking about. They're bent like that. All right. So that's the footings, and here's the footing chart. Okay. So remember the F2 and F3 and all that. That's right here. Okay. So if you have an F2, the A dimension is 2 feet. The depth is to match the beam depth. And reinforcing, you have 2 number 6 bar X. Those are the bent bars that they're talking about, and you have top and bottom. Okay. If you have an F3, it's also 2 feet on the A dimension. And then same thing, you match the beam depth, and on this one you put 4 number 6 bars, top and bottom. So the F2 has 2 bars, the F3 has 4 bars, and the F4 you have same thing, 2 feet, match beam depth, but the same thing, you have 2 bent bars. Okay, so that's where we're at so far. Okay, that's what all these are. Okay, so we're getting there. Any questions so far? Cambia la pantalla, ya la cambié, sorry. Okay, did you guys see that? I think I switched the screens. Eric, your guys pour concrete, do the rod busters, or different crew do rebar? I get rod busters to do my rebar. So, and then I get finishers when we pour concrete. So anyway, that's where we're at right now. Okay, so you pretty much have so far everything you need to verify that the slab is done correctly. Okay, you know what size rebar you need, where it goes, beam depths, those footings, everything you have. Okay, now here's something else. Let me switch screens before I forget. So let me see. See this line right here? It's got like diagonal lines on it. That just means you're gonna have stone or brick. That's a brick lug. Okay, that's what that means. Okay, so in this particular home, it's gonna have stone across the front. That's what that means. That's all. Nothing major. Right here, you have to slope the floor towards the front. And of course you have to look at your code, but it's typically 1/4 inch per foot. Okay, so here, see this right here? It says 1.5 inches. That means you're gonna have a 1.5 inch drop from this surface to this one. And then once you get onto this one, then you need to slope this way. Okay, so all that needs to be accounted for. Okay, so be very careful that you don't miss any of that. Okay, back to the second one. Again, you have all your details on this page. They draw everything out. See those hairpins? We also have those hairpins on the first page. Let me show you what I'm talking about when I say the hairpins. These right here. All these hairpins right here. Okay, all those are down here. Tells you the dimension. So you can see right here, they're 8 feet by 8 feet, and then they have 1 foot in the center. Right here is 1 foot. Okay, and so they tell you where they go, what size they are, all that good stuff. Okay, and again, just everything's here. If you have trees or anything, you have a detail right here for how to deal with roots. So it's all here. Okay, now here's something very important. Okay, if there is something about these plants that you do not understand, call the engineer. They will answer your questions. Obviously, they don't like it when you call them with very basic questions, such as, you know, hey, I don't understand this dimension over here or whatever. I mean, you don't want to bother them with minor stuff. But if there's something that you really need to know, call them up. Ask them, because trust me, they would rather answer your question than have to go way out there wherever your house is at and fail your inspection and delay your pour and just cost you a just nightmare. So call them up if you have a question. Okay, all right, let's go back to the plans now. Okay, Blair is asking, what's tying the footers back to the hairpins? Well, we have rebar in there. I don't know if that's what you're asking, but we also have our anchor plates. See this right here? We have this is where we put our anchor plates to tie our pipes or to weld our pipes for a metal building. That's where the anchor plate goes. And of course, everything's tied, you know, with rebar. Not entirely sure this portrays to what you're going over, so sorry if I derail you. Do you ever do waffle slabs? That's what we have in the concrete plan. Looks way different than this. We pour tomorrow. I don't know what you mean by waffle plans. I think this is a waffle plan. This is just not a very big slab. But see, you know, right here, this looks like a waffle. See that? I don't know if that's what you mean. The hairpin is the anchor for the footers. No, it is not the anchor for the footer. The hairpin is meant to transfer the flex. In case there is flex, that's where those hairpins are sticking out 8 feet to help with the flex in case that pipe wants to flex. That's what that's for. And of course, they're tied to the mat steel. Okay, and of course the mat steel is tied to the to all the beams. So that's what the hairpins do. Okay. All right, back to the plans. We're almost there. Okay. Here is the last. Oh, wrong button. Here's the last thing that we need to talk about. Okay, where are we at? Okay, let me go to the second page. Okay, right here. Foundation general notes. Again, read all these notes, okay? Because this is very important. Number 1, the code basis for the foundation is design IRC 2018. This foundation has been designed as soil supported, stiffened grid type beam and slab foundation and such will move with soils upon which it bears. So this is a floating foundation. It's meant to move, and if it moves, then it moves. It's not supposed to break off, okay? Oh, here's something interesting that people give me a lot of heck for every time we show our foundations. Do you see that they are not calling for any expansion joints? Typically, a lot of I guess up north they call for expansion joints. Notice that we are not required to do expansion joints, and a lot of people say, you know, concrete guys are funny crowd. I did a video about a week ago on a foundation that we were chasing some cracks and filling them in, and you know, kind of showing them what we're doing. And oh my goodness, they're like, well, you should have done expansion joints, and if you had done expansion joints, and you're an idiot, and if you had just done this, whatever. Look at these plans. They are engineered and they are not requiring any expansion joints. So that's how we do it. Okay, so again, do what your engineer asks for. Okay, all right, back to the plans. All right, let me read a few comments real quick. Oh yeah, Texas forever. He says, yep, that's what he meant. Yeah, so this is a waffle foundation. It's not super big. Obviously, it looks a little better. Not better, but it's more noticeable when you have like a really big foundation. I've never poured concrete or have plans to pour. I'm just here for the free education. Is that weird? No, sir, not at all. Learn all you can. I call it a monolithic slab. Well, a monolithic slab it just means that it was poured all at once. So if we were to do this slab and we pour the house portion first and then come back later and do the porches, it is no longer a monolithic slab. Monolithic just means it was all poured at one time. And I've seen some other people on YouTube that they, and not only on YouTube, I mean in general, they'll pour the foundation slab, and then they'll come in and do the porches as flat work, meaning no beams, no anything. Obviously, it's a lot cheaper that way, and you know, but it's not as good. They would never pass inspection if. That's one way to tell that it is not an engineered foundation. If they are doing the main slab first and then they're doing all the porches separate, that is not an engineered foundation because they would never pass inspection. So keep that in mind. All right. Let's, yeah, somebody's asking about post frame. Yeah, R&R Buildings. Kyle does post frame. He's the post frame guru. We do metal. Okay, moving on. Let's go to page 2. Okay, we started reading these notes right here. These are super important. Okay, let me try to zoom in so you guys can see. All right. D-Hyde, I'm in Dallas. We have expansion joints in our driveways. Yeah, no, we do expansion joints on driveways for sure, but we don't ever do them on foundations. Hey J-Rod, you have people watching from Sesisk now. Awesome, man. Awesome. I'm glad they're here. I hope they can learn something. You know, there's a lot of knowledgeable people there, and obviously I'm just here trying to help. All right, so again, read everything. Literally read. Okay, contract, here you go. Right here. Again, contractors to verify all dimensions, drop areas, floor penetrations, and block out locations with architect's floor plan. Right here, with architect's floor plan. The contractor shall verify any deviation from the information on this foundation design with G. Reeves. So, again, it's on you, contractor, builder. You know, a lot of people want to build their own Barndominiums. That's great. You know, obviously I help everyone. However, this is very important that once you do that, you are taking on all the responsibility. Okay. C, the contractor architect shall notify G. Reeves Engineering of any inconsistencies, omissions, or errors in these plans, and the engineer's decision as to revision shall be final. What does that mean? The contractor or architect shall notify G. Reeves of any inconsistencies. Pretty much they're saying, check our plans. If they're wrong, it's up to you to let us know. Okay, that's what that means. So again, you are taking all the responsibility. So be very careful. If you are a concrete contractor, it's on you. If you are the builder, it's also on you. The architect, it's on everybody except on the engineer. So yeah, be careful. All right, let's keep going. D, obviously these are our plans, or not our plans, but the plans that we had designed for this foundation. So yours will likely be different, but again, you need to read everything. The contractor shall not place any concrete until G. Reeves Engineering has conducted a pre-pour inspection and has given approval to place concrete. Please contact G. Reeves Engineering 24 hours in advance to schedule inspections. This is back to, like I was saying earlier, you need to schedule your inspection, and until you have a pre-pour inspection passed, you don't have an engineer foundation. Okay, you have an engineer foundation design, but not an engineer foundation, because if it was not done the way they asked you to do it, then it's wrong. Okay, and you have nothing until then. Contractors shall call G. Reeves if foundation requires multiple concrete pours of 3 or more. Okay, contractor shall furnish labor, materials, equipment, supervision necessary to perform all work shown on plans and specifications. That's pretty standard. Right here, here's another one. It is responsibility of the builder or contractor to notify the homeowner of the importance of items 2C and 2D below and the limitations as expressed in item number 1 above. No other warranties are expressed or implied. All right, what does that mean? All right, 2C right here, 2C and 2D. Right here, here's 2, here's C. Okay, it says positive drainage away from the perimeter of the finished foundation must be provided. The top of the foundation slab should be a minimum of 8 inches above the finished grade. The ground adjacent to the foundation shall slope away a minimum of 6 inches in the first 5 feet. That just means you need to have your ground sloping away from the foundation so that water doesn't puddle around it. Okay, that's what that means. Okay, that's 2C. 2D, they even circled it, or they outlined it right here. Okay, foundation forms are to be situated sufficiently high enough above grade to allow for final grades to provide drainage to conform to the current IRC specifications. GRE Incorporated pre-pour observation will include pass-fail comment issued by the field inspector. Field inspector will include measurements from the proposed type of concrete, existing grade at minimum of 4 exterior corners. The minimum form height above construction grade is to be 12 inches. Proper drainage is the responsibility of the builder. Right here, okay? So the builder has a ton of responsibility, okay? I mean, a ton. So again, if you want to be your own builder, I just want you to understand that the builder has a lot of responsibilities. And obviously, if a builder hires you to do the concrete, then you have a lot of responsibility, okay? Because the builder can just simply pawn this off on you, and you need to know this. If you pour this entire foundation and you're only 6 inches off the ground, guess what, buddy? You may have to either add on to it or again, be very careful, okay? Extremely careful. A lot of times, the builder will ask you not to go as high because, I don't know, they're trying to save fill dirt, or they're trying to something, right? So, the concrete guy, the contractor, he may say, yeah, not a problem. We'll just do a 2x6, no problem. And they'll do it. And guess what? If you don't pass inspection, the builder's just going to say, well, you're the expert here. You're supposed to know these things, So do not deviate from these plans, okay? So anyway, let's go back to it. Area of foundation is to be clear of all organic materials down to solid base. So that just means clear all your grass. Yes, grass is not a fiber reinforcement material. The next one, provide vapor barrier beneath the floor slab by using a waterproofing membrane of 6 mil polyethylene. The membrane shall be taped at all splices and tears. Right here, very important. I'm gonna read it again. The membrane shall be taped at all splices and tears. Every time you lay your poly, every seam you need to tape it. If they make a tear, for example, they go in over plumbing pipes or any of that, tape it. It all needs to be taped, okay? They can't fail you for that, so be very careful. All right, keep on going. All trees planted after placement of foundation shall be planted no closer to the foundation than 1.5 the potential height of the trees. So be careful. Don't plant trees too close to your foundation. Here's another one. All air conditioning condenser drains should discharge a minimum of 5 feet from the perimeter of foundation. So don't dump your water right on the edge of the foundation, because it will. So what's going to happen is it's going to add too much moisture to one side of the house. And if you have expansive soil, it's literally going to lift your entire house. And it's going to cause stress, and you're going to get cracks. So be very careful. Flower beds is another big one. A lot of people, they do a lot of people do flower beds around the perimeter, or maybe just one side of the house, and they water them, and I mean, they look great, but they're bad for your foundation, so careful. Fill materials shall meet TxDOT type A grade 1 or 2 flexible base requirements. A minimum of 6 inches of select fill is required. What does that mean? Don't just put any kind of dirt in there, okay? It needs to be select fill. And depending on where you're at, we're in Texas, so, they have already grades of fill that are approved. So that's what you need to use. Again, don't go dig a hole in your yard and put it in here for your foundation, because they will make you dig it all out. So don't do that. All right. Concrete. All right. Concrete shall be a minimum compressive strength of 3,000 psi at 28 days. It should be in accordance with ACI 301. Cement shall be type 1, and fly ash, if used, shall be Monex Resources Class C. If fly ash is used, it shall not exceed 20% of the total amount of fly ash and cement used by weight. Contractor shall satisfy himself that the mix is acceptable for its intended purpose. Again, I'm gonna say that I'm gonna read again. Contractor shall satisfy himself that the mix is acceptable. So if your foundation fails and it's because of the concrete, it's on the contractor. And if you are your own builder, it's on you. So you cannot just blame the concrete company. Let me see. Let me read some comments. See how you guys are. See if you guys have any questions. D Hyde, this is awesome. Thank you, sir. You're welcome. I love what you're doing. You have a very unique channel. Thank you. Thank you very much. AJ Rod, this is this is badass. Thank you, sir. The note said flexible base. It's different than select fill. Let me see. Let me go back. Grade 1 or a minimum of 6 inches of select fill is required. Again, it's just not any type of dirt. You have to use good dirt. All right, let's keep on trucking. Concrete shall be placed and cured in accordance to ACI 302.1R. Finish tolerance shall be in accordance to ACI 117. A minimum set of 2 test cylinders for 28-day compressive strength tests are recommended. Okay, in accordance to ASTM C39. So they recommend that you take some cylinders for to do some compressive testing. We actually don't do that, but we need to. I want to be able to have that information. All right, here we go. Grade beams. Grade beam depths may be reduced. Here you go. So for example, if you get to, we're in the hill country, right? A lot of times we do work in the hill country. And if you run into a place that has a lot of stone, a lot of rock, then again, this is why it's very important that you read everything before you even get started, okay? Right here. Grade beam depths may be reduced to a minimum of 14 inches if the beam is bearing on solid rock. Reduced beam lengths are limited to a maximum of 5 feet in any 20-foot run. If additional reduced lengths are needed, contact the engineer for additional requirements. So if you have 20 feet, you can actually reduce that beam depth to 14 inches if you are on solid rock, but only for 5 feet, okay? So if you have a big rock that spans like 10 feet, you need to dig 5 feet of those out down to 27 inches. And for 5 of those feet, you can leave it at 14 inches. So again, be very careful. And obviously, if you have more than that, you can call the engineers and they'll tell you what you can do. So grade beam depths in excess of 36 inches, increase the amount of reinforcement steel by 2 number bars horizontally every 18 inches of vertical and exterior beams. So that just means if you have a beam that's more than 36 inches deep, then you need to put 2 mid bars, okay? And that's all that means. And every 18 inches. So if you have a beam that's 48 inches, then you do 2 sets of mid bars. That's what that means. Reinforcement bars shall be billet steel, deformed bars conforming to ASTM A615-03. grade 60. All right here, very important that you get grade 60. Well, at least we need to get grade 60. There's different grades of rebar, okay? Obviously, grade 60 is more expensive than grade, I think the other one's 40 or 20 or 30. I don't remember what it is. I think they're 40, grade 40. So very important that you do not go and buy some grade 40 because they're cheaper. You're going to save a bunch of money, and then you put it all in and you don't pass inspection, and then you have to take it all out and replace it with grade 60. So it all matters, okay? So again, grade 60. Laps and splices, a minimum of 40 bar diameters. We discussed this earlier. If you have 1/2 inch rebar times 40, it's 20 inches minimum splice, okay? All beams and slab reinforcing bars should be supported with plastic chairs or concrete bricks in accordance with IBC chapter 19, blah, blah, blah. That just means support your rebar. Don't let it sit on the ground. So this is funny. Now that I'm going to mention this, you guys are going to go and check it out. Every time you see a concrete video on YouTube or Facebook or anywhere, and you see that the rebar is on the ground, immediately go to the comment section and see how long it takes you for somebody to mention that the rebar is on the ground, because that is a huge no-no. And concrete guys, they like to pick on other concrete guys if the rebar's on the ground, because that is like concrete 101, okay? A lot of times they will actually lift the rebar as they're pouring. But anyway, just keep that in mind next time you see a concrete video, and if the rebar's on the ground, go to the comment section. All right, let's see, we have 30-inch beams. Texas forever. We have 30-inch beams and use number 5 top and bottom, but not in the middle. We use grade 40. I'm somewhat concerned now. Yeah, well, if it was engineered, you need to talk to the engineer. But anyway, yeah, use grade 60. It's not worth the money. They ask when I order rebar if I want domestic or imported. Domestic, buddy. All rebar was set 12 inches squares. What's your yearly income? Really? You guys are asking me that? Erik, that falls under a special category called none of your effing. I guess he was answering to Eric 12. Okay. Also, will the vibrate machine smash the rebar chairs? If you're not careful, they can. You just have to be careful. Vibrators, if you guys have seen any of our videos, we use vibrators on everything. But you have to be careful. You can blow out a form with a vibrator, so be very careful. Anyway, let's go back. Right here, all bars should have a minimum of 3 inches from the bottom and sides of the beams. Slab reinforcement shall be in mid-plane. What that means is, back to your bricks, okay? Your beams need to be wide enough that your stirrups don't touch anything. Your rebar should not touch ground, forms, anything. They need to be 3 inches clear everywhere. Obviously on the mat, you only have 2 inches, right? Because you need it says right here. So again, this is one of those that you need to read very carefully. It says right here, all bars should have a minimum clear cover of 3 inches from the bottom and sides of the beams. Okay, so that's the beam reinforcement. Okay, slab reinforcement shall be in mid-plane. So everything in your beams has to have 3 inches all the way around. On the mat, on your plane, on your slab reinforcement on the top of your slab where it's 4 inches thick, it says it shall be in mid-plane, meaning right in the center. So 2 inches. Okay, so 3 inches everywhere else, mid-plane, so only 2 inches on the surface. Okay. Um, corner reinforcement bars, 2 bars at each corner of the perimeter grade beam, blah, blah, blah. It just tells you that you need 2 corners. Construction for all foundation drops in excess of 3 feet. The contractor shall construct a French drain system capacity sufficient to intercept and transport water from beneath the foundation, blah, 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 blah. So again, just details that you need to do if you have special details, you know. All foundations that are to have a fill depth greater than 2 feet below bottom of interior grade beam shall meet one of the following. Interior beams may be deepened to maintain a 2 feet maximum depth of fill below the bottom of the beam. Intermediate bars per note 4B shall be added if required. If bearing in solid rock, 14 inches pier diameters formed with sonotubes shall be placed at all interior beam intersections. Piers are to be reinforced with a minimum of number 4 vertical bars and number 3 ties at 12 inches on center vertically. Refer to detail 13. Let's go to detail 13 so we can see what they're asking. There's 15. Come on. 13 right here. It tells you how to do the piers right there. All right, so it's all here. It's all on your plans, okay? If earth is supported, select fill equal to text dot number 2 base, 15 pi max shall be placed in 8-inch loose lifts and consolidating using vibratory method. So if you have a lot of fill to build up, you need to, well, you can do one of these. You have options, okay? So pick the best one and go with that. Where pipes pass through beams, increase beam size at pipe penetration to maintain minimum beam width and height. Placement of oversized diameter sleeves is also recommended. Okay. So this is an interesting one. Okay. A lot of times the plumbers, see, you have your beams, right? And you know, they're dug and you have your rebar and all that good stuff. And a lot of times the plumbers, especially when they're running PEX lines, it's really easy just to run the PEX line down the beam. I mean, they just run the whole thing, they run it in, they pull it, and you know, they can go 40 feet, no problem. It is not going to be allowed by the engineers. Not gonna fly, okay? That is actually every pipe that you run inside that beam. So check it out over here. See, your stirrup looks like this. Okay. You should not have anything inside of here. Okay. Anything that you put in here is taking away concrete, and this is where it's the reinforcement beam gets its strength. Okay. So if you're gonna run any pipes, what they're saying is, here's your beam. Okay. And your stirrups are in here with your beam, right? If you're gonna run pipes or anything, you need to make the beam deeper or anything so that you can run pipes down here or on the side or wherever. It just needs to be outside of your stirrup. So if you're gonna do that, make sure you plan accordingly, okay? And do not let your plumbers run pipes inside the beam because you're going to fail inspection, okay? And I don't know how many of you, see, I'm a builder now, so it's a lot easier. But back then, when I was only a concrete contractor, I used to fight with plumbers all the time because they just want to run the pipes down the beam because it's really easy. But of course, they'd run all their pipes, collect the check, go home, inspector shows up, I fail inspection because of them. Not cool, man, not cool. So be very careful with that. All right, what else? Contractors should provide positive drainage away from slab perimeter during construction. Same deal as earlier. Make sure you don't have water puddling around your foundation. Concrete shall not be placed on soils that have been disturbed by rainfall or seepage. And all bearing surface shall be free of loose soil, ponded water, debris to placing prior to placing concrete. So if everything's ready to go, you're ready, everything's verified, everything's good to go, and it rains, you're not pouring. You cannot pour. So we carry pumps in the trailer to pump water out, because the minute it rains, you need to get somebody out there. It doesn't matter if it's 5 a.m. or whatever. You need to get somebody out to the job site and pump all that water out of those beams, because if that water sits in those beams, water's going to seek the lowest level, which is your reinforcement beams. Okay, water's going to, if you have a big rain, those beams are going to fill up, and it's going to soak everything, and then your waffle is going to collapse. Okay, and now you have a real nightmare on your hands. If you go and you pump all that water out immediately, it's a lot better, and it's going to dry out a lot faster. Okay, so make sure you do that. And obviously, if it's wet, they're not going to let you pour. So you shouldn't pour. Okay, almost done. Concrete anchors placed, 1/2 inch embedded anchors. So if you're doing a like a residential foundation, not a barndominium, you need to put anchor bolts all the way around. Okay, every 4 feet on center, and a minimum of 2 anchors, bolts per wall. Bolt placement shall commence 12 inches from exterior corners. May use mud seal anchors per manufacturer's guidelines, all in accordance with IRC section 403.1.6. So that just means you need to put anchor bolts. For barndominiums, we don't need them because we have anchor plates, and but then when we do interior walls, then we anchor those to the concrete. So, all right, man, that was a lot, but I hope you guys learned something, because there is a lot on these plans, but you need to read them. If you don't read them, you're gonna fail your inspection, or worse, you're gonna pass it, and then you just built a subpar foundation, and then you paid all that money, all that time for nothing. Okay, so be very careful. All right, let's read some comments now. Erik Paz, thank you, Erik. I'm learning so much. Thank you mucho. You're welcome, sir. Okay, there's somebody else, but I don't understand his comment. Only on paving machine I've seen. I guess you guys are answering questions to somebody else. So, anyway, any other questions before we go? I hope this helps some of you guys. And again, very important that you follow the engineer plans, or you're going to fail. It's that simple. Love your lives. Well, thank you. I'm going to try to do more live streams. If you guys haven't figured it out, I like educating. I like passing on what I know, because you know what? This is how I learn. I'm just paying it forward. A lot of people have helped me throughout the years, and this is how I pay it forward. Plus, I like educating my customers, potential customers, and because this really helps them see how we do things. And not only that, I think it just makes everybody better if we have some kind of standard. What size rock do you guys typically have in your mix? He's asking the size of rock that we use in our concrete. It's typically 1.5 inches. I thought the quality of your detailed drawings was very good. Well, thank you. Why did you get away from post tension? I will do a separate video about that, but it's mainly because it was really hard to coordinate everybody. It just took too long. But I was very happy with the performance. I was just not excited about how long it took to do a post tension foundation. Thank you for sharing your knowledge. Well, thank you. You're welcome. Steve Larison. Thanks. Learn from you again. Take care. Thank you, Ramon. Great video. Thank you. Well, thank you, guys. Are you liking your roller bug? Yes, I am. I'm really liking the roller bug. What determines why you would use a post-tension slab? They're both great. I consult with your engineer and ask them what they recommend for your type of soil. But most of the time it doesn't really matter. If you have a rectangle foundation, kind of like what we have on all of our homes, post-tension works great. If you have a foundation that's very cut up like this, let's just say this foundation was like this, and then you had a window, or I don't know, you've seen those custom homes, how they have just concrete is never straight, and then they have some like this, anyway, this you would do rebar for sure, because post tension works best if you have a grid like this, you know what I mean? And if you have crazy kickouts like typical custom homes tend to have, then you need to do a lot of short cables and a lot of crazy stuff. So it's better to just do rebar in those foundations. So they have their place. Focus was a little off, but content was very important. What do you mean focus? On my camera? Now you got me. We've been binging your videos during quarantine. Love your content and the comedy between you and your crew. Well, thank you, Texas Forever. We have fun, man. We enjoy it. Can you show us the detail on your shower drains? I don't know what you mean by that. I'm sorry. What would you do is, all right, what we would do is use tie wire to hold up the cables instead of the nails, so we could wreck the forms the same day. Yeah, that would work, but we still have to wait for the engineers, so it's a nightmare. Can you put up a commercial plan and also show us how to read survey stakes? I'll probably do that some other time. I think the next plan or the next video that I'm going to do live stream is going to be on reading the architectural plans. Because reading plans is extremely important. And as you guys saw on these plans, they keep talking about how, don't trust these plans, trust the architectural plans. So obviously you need to be able to learn both or be able to read both. So very important. All right, guys, holy smokes, this is a long one. Hour and 23 minutes. So I guess I better wrap it up. AJ, thanks for being here, man. I appreciate it. And thank you for doing what you do. Any other questions? Leave it on the comments below. And a few more comments, and then we'll get out of here. Really appreciate that you take the time to explain the details and enjoy your build videos. Except now I'm hankering to get into Barndo myself. Good. You gotta live that Barndominium life, man. Thanks for the details, very helpful and interesting. Well, thank you, Jeff Henderson. I appreciate it. Vicente de la Cruz, greetings from San Angelo, Texas. We got our plans last week, and your videos will help during the build to know the great quality looks like. I'll keep up the awesome work. Thank you, sir. All right, guys and ladies out there, thank you for joining us, and share this with your friends if you think it'll help them. All right, we'll see you guys next time. Brandon's channel says I spelled my name wrong. No, sir, I do not. All right, we'll see you guys next time. Yeah, don't forget the thumbs up. We'll see you guys next time. We are Texas Barndominiums.